up a nice library of our PowerBI4Enviro's meetup sessions. So we'll share those on our YouTube, on Discovery Eye's YouTube and blog as well afterwards. If you think any of your colleagues or co-workers might be interested, you'll be able to find the link. I'll just start sharing screens. Amazing. Welcome everyone to today's session. As I mentioned, we're the PowerBI4Enviro's meetup group. So our group is really about sharing interesting case studies, learning new tips and tricks all across the environmental industry and empowering other environmental professionals on their Power BI journey. So our group tends to be a blend of people who love Power BI and want to see different applications for it across the enviro industry, all the way up to people who work in the environmental industry and are really curious about Power BI and haven't really used it yet. So we get all sorts of people. So thank you so much for dialing in today. Just a bit of housekeeping. Please mute your microphone when you're not speaking. If you have any questions, please type it in the chat and we'll try to answer them directly in the chat, or we might do a Q&A session just at the end of today's session as well. So feel free to go off mute to ask your question. So as I mentioned, the session is being recorded. And if you did want to zoom in on any content, just a tip, you can hold Control and scroll with your mouse to zoom in. Just an acknowledgement of country from where I'm dialing in today, in Perth, Western Australia. So I'd like to acknowledge the Bibliman people as the traditional owners of the land on which we're dialing in from today, and pay our respect to the Whadjuk people, their elders, both past and present, and also pay respect to the traditional owners of the land on which Daniel's dialing in from and everyone else on the call is as well. Thank you to our event sponsors, Discovery Eye. So myself and Christian and Daniel, we work at Discovery Eye, and our mission is really to transform environmental data into decisions. So we do a whole range of things from Power BI training, report development, a little bit of infographics and animations with Renat, and sometimes some custom web applications, or Daniel does. We help. But into today's session, why we're all here today. This session's all about visualizing guidelines and exceedances in Power BI. So we often assess environmental data against one or many guidelines, and it can be notoriously challenging to model, calculate, and visualize inside of Power BI. So what I'm going to do today is I'm going to explore some real world tips and tricks for working with guidelines and exceedances in Power BI. And Daniel will showcase a custom Deneb visual that he created to highlight water quality exceedances over time and share his lessons learned for improving the rendering efficiency of these visuals. So our speakers, I'm Alice, I've also got Daniel, he's presenting as well. So we both work at Discovery Eye. And we specialize in creating environmental Power BI reports. So very brief overview. He's an MVP for the data platform, and he blends his loves of kind of database design with DAX and Power BI report development, but really custom visual development's his new passion, in particular the Deneb visual that he's created for the Power BI community. So let's get into it. So I'm going to start us off today by sharing some real world case studies of how we might go about modeling, visualizing, and kind of computing guidelines in Power BI. But let's take a step back and just discuss the complexities of environmental guidelines in Power BI. And even before that, we did just chatting before the session. Just for those of you who aren't so familiar with what a guideline is and what I mean by it, often in environmental monitoring, we're monitoring things like, say, the water quality of our surface water and groundwater systems. So things like pH, electrical conductivity, total dissolved solids, and we want to assess to make sure that the water, we want to assess the quality of the water against certain values or guidelines or triggers to make sure that it's safe for things like drinking water or recreational water use. And there's a lot of different values that we might want to assess against. So that's the problem that we want to chat through today. And the complexities of environmental guidelines are there could be many guidelines per analyte. So for example, for pH, we could assess it against the drinking water standards or the recreational use. There could be lots of different other guideline descriptions. So there could also be guidelines that might vary per site. So say we've got upland river monitoring sites versus lowland river monitoring sites. They may have different values for the guideline, even if it's the drinking water guidelines. The value for pH might change depending on where you are in your system. And then the guidelines, they might vary over time. So we might change what that standard is for maybe every year or every quarter, or it could just be ad hoc when a guideline standard changes. And these guidelines, they may also change based on the data. So we could have data-driven guidelines or thresholds based on things like 95th percentile or a rolling average, or even we've seen another parameter such as like EC driving what the guideline value should be for total dissolved solids. So these are tricky. Then we have to think about how we want to model the data, how are we going to compute the number of exceedances, and how do we want to visualize this in charts and tables? So what I'm going to do today is review a couple of common scenarios. So we'll start with the simplest first, just one guideline per analyte, and the value doesn't change over time or space. Then we'll have a look at the scenario, which is probably the most common, multiple guidelines per analyte. And then a little bit more complex, multiple guidelines per analyte that vary over time and change based on the data. So these are data-driven guidelines. And then Daniel will chat about where we can't achieve what we want with the core visuals in Power BI, having a look at how we can customize a visual to display meter-specific guidelines. So let's get into it. Let's have a look at the first scenario. So one guideline per analyte. We'll start simple. So this is a synthetic data set that we've got in Power BI to have a look at groundwater quality across lots of sites for lots of analyte. And if we have a look at the data set here in regards to the guideline values, you can see that for each analyte, we've just got one guideline value. So this is pretty much as simple as it gets. So these don't change over time. They don't change based on where you are in a system. Let's have a look at how we modeled this scenario. So we've got our floor or our site details, we've got our date, we've got our guidelines, and this is joined up to our fact table, so our groundwater samples, based on analyte. So here we can have a really nice star schema. And how we're actually computing what an exceedance is or not is by using DAX. So DAX is Power BI's calculation language, and it allows us to compute measures to store or flag whether or not we have exceeded a certain guideline. So we're using a DAX pattern here with the function calculate, just really to count the number of rows in my sampling table where my sampling value exceeds or is greater than the guideline value. So this is really neat because then we could bring this calculation into a range of different visuals. We could bring it in up here to show us at a glance how many exceedances have we got. So for this one analyte, we've got 383 total exceedances across all of our monitoring locations. We could bring it into this visual here, this mapping visual, and size the points by the number of exceedances. So you can see for a larger dot, that implies you've got more exceedances. We could bring it into a matrix here. This matrix shows all of our water quality sampling results, and it's highlighted using conditional formatting whether or not we've got an exceedance. You could have a look at it in a bar chart here. Again, just showing different ways of breaking this data down so that we can see for each site how many exceedances are there. And then we can see over time, here if I filter on just one site, we can see our concentration over time compared to the guideline value here. And what I want to do quickly is just draw your attention to this time series chart, because this is always a challenge of ours. How do we visualize time series trends of water quality samples against guideline values? So let's explore this one in a little bit more detail here. Bring it over here. We often wouldn't want to show the average concentration of all bores against the guideline. We don't really want to average it. What we would typically want to show is what are the time series of all of our monitoring locations, and then have a dashed line to show what the guideline is. If we try to split this up how you would tend to do in Power BI by bringing bore into the legend, you can see that that won't let us do it because we've already got two fields in the y-axis. So what we have to do is take out our guideline value. We can bring bore ID in and now split this chart up. And now we've got time series chart for each of these bores. But now what we need is how do we bring that guideline value in? So what we can do if we have just one analyte selected is we can use the analytics pane. So this is an option available to us. We could bring in a y-axis constant line, call this guideline, and we can use conditional formatting to kind of data drive what this value is. So here, what we want to do is connect up to the guideline. It's going to bring in, say, the average guideline value, because we just have one value per analyte. And you can see that that's displayed here. When we hover, because we're using it from the analytics pane, it doesn't provide us that info in the on hover tooltip. What we could do is we could put a data label on, and we could label it with the data value and the name. And if we want to, we could also bring it into the visual tooltip here by dragging into the tooltip field. So this is one option, and this works okay. You can see it's got a couple of annoying factors, like with the label, it doesn't have a halo or a background on it. So sometimes the contrast is really bad. That's a small minor thing, but often we want to see multiple analytes at a time or plot multiple guidelines on the chart, and that's where it gets a little bit more complex. So let's take a look at another example. So this was a simple one where we've got one guideline per analyte. Let's have a look if we've got multiple guidelines per analyte. So this is another synthetic data set. Let's quickly show you what the data looks like. What have we got here? Guideline values. You can see for every analyte, so we've got codes here, 10 codes. We could have more than one guideline. So for this one, XYZ015, we've got aesthetic guidelines for Australian drinking water guidelines, and we've got recreational water quality guidelines. They've got two different triggers for the one analyte. Now I want to show you a couple of approaches that we go through to model this. here we've got our guideline values, and we've actually separated it out. We've separated out our data into its own discrete exceedance tables. This is the first method. Have a look at our data here. We did a little bit of pre-processing up in Power Query to create an exceedance table. And what this is it's all of our sampling results repeated for each of the guidelines. And then we're flagging whether or not it is an exceedance with a 1 or a 0. So this approach is great because it allows us to simplify our DAX, and it works for most visuals. It's not so good because we have to do a bit of extra pre-processing in Power Query, which could be a bit slow. And also it's duplicating our data. You can see here we've got our actual sampling results, and then we've got our exceedances duplicated. So if you have a really big study, it might not be feasible. It might make your report or the size of your Power BI file quite big. So another approach that we could take is using DAX. So very similar to that other example I showed you, we could compute exceedances by using a DAX expression to count the number of rows based on some filter. But this does get tricky thinking about how do we want to visualize it in visuals. We might get into the realms of iterators if we want to aggregate up this data. So really, it's an it depends situation here. But let's have a look at a couple of ways of visualizing this type of data. So hopefully this is giving you a flavor for the type of challenges we can experience, but also spark a couple of ideas for how we could go about visualizing this. So one way, which is really nice when we're thinking about exceedances above certain guidelines, is to not show all the data at once, but we are just really interested in the exceedances. So where do we potentially have a problem? And this can be a short list of all of your data. So you can see here that we've got a summary for aluminium. We've got 11 exceedances above this guideline, 12 exceedances above this guideline, and 2 above this. And you can drill in to have a look at the specific details. You can see this is all just for one site, and you can see the specific dates on which this occurred, as well as the concentration and the guideline range. So while this is a matrix and it's not so visually appealing, it could be actually really quite useful for people if they wanted to see that short list of values. Again, we could have a conditional formatted table. I might just filter it for one parameter here. So for pH, here we've got like a heat map style one, and we can see what we can do on hover is we could have a tooltip which lists all of the applicable guidelines for this parameter, and it highlights which ones have been exceeded. We'll see if there is, you can see all of these have been, but if I choose maybe another, hard to see with fake data, but you could imagine if only one is exceeded, then it will just show, it'll just show that one. So you can see all of the guidelines which it would be assessed against. I can't find one off the top of my head here. But it shows a really nice shortlist. So if we have a look at pH again, we could imagine if we're having a look at data, here, outside of that range, it just shows, it just highlights that one guideline which was exceeded. And if we have a look at this again on a time series chart, here we're using that same technique of visualizing these guidelines using the analytics pane. But we can see a couple of challenges that it presents because here, if we have a look, we've got 4 different guideline ranges and they have different values, especially for the upper limit. But we can't, it's really hard to systematically put in all of the different lines here because we are actually kind of hard coding it in. We're just getting the minimum and maximum aggregated up for those guidelines. We can't put in every single line that is applicable. And that's where it gets a little bit tricky. And again, if we've got more than one analyte selected, so if I clear this, we're only displaying this chart where we have one analyte selected. So people might like to see a small multiple chart so we could scroll through and assess multiple. So that's another challenge that it presents. So let's have a look at our last scenario where we can see multiple guidelines per analyte. They vary over time, and the guidelines themselves are actually based on the data. So this is another example using synthetic data into the future. Having a look at groundwater level triggers. So you can imagine these not so much as guidelines, it's not the drinking water guidelines, but these are set triggers that you want to assess, and you want your monitoring bores to stay within certain triggers. If we have a look here we can see that same matrix table again, where we're conditionally formatting values which are based on the guidelines or triggers or thresholds. But this time you can see that we're changing the color based on what trigger is exceeded. So if we have a look at these, we've got site-specific triggers based on whether it's more than 10 centimeters below the quarterly average level, or 15 centimeters, or 20, or 25. So they're staged kind of triggers so that you know what order they would be triggered in. So for example, with this one here, if it's trigger C, which is more than 20 centimeters below the quarterly average, you know that that is also exceeding trigger B and A as well. So you could think about that and having, playing around with your conditional formatting to show a bit more detail there. So not just flagging whether or not something's been exceeded, but somehow communicating to your report user what one has been exceeded. We have a look here, it's always, even though this is a really ugly visual, it's always really useful for time varying site specific triggers or guidelines to show it in a matrix so that people know what the triggers are over time. And then if we have a look at the chart, so our hero visual, usually the time series chart, what we're showing here is usually what we want to display. We want to see our actual data. We've got groundwater logger data and manual dip data against those different triggers. And what we're doing here is, because we've got such highly customized data, we can actually create individual measures to bring them all in. So you'll note that we are not splitting up our data as a legend against multiple bores. We can't show all the bores on the one chart because each bore has different triggers. So it actually makes it simpler. We've got individual measures here to bring in. All the triggers for each bore have the same name, which makes it a lot easier. It gets tricky when you've got different names for these different guidelines. And we're using small multiples to split it into these charts based on the different bore IDs. So this is a nice way of visualizing it as well. So hopefully that's given you a bit of a flavour for some of the complexities involved in modelling guidelines in Power BI, some of the challenges that we're faced with, but also some ideas for different ways that we can model and calculate it and visualise this type of data. I might pause just for a couple of the questions we've got. We just got two. So question, will we be able to share the Power BI report? These are some Power BI reports that we do use in our Power BI training. We run a series of training courses, Power BI for environmental professionals. So no, we can't share them, unfortunately. Another question from Sophie, what did you use for the legend for the matrix? Let me have a quick look. Yeah, so it would be that one, I think. So this one is actually a matrix visual itself. So I've got the ID above it with, I think I'm using white text. So you can see these are just some numbers, and then I've just done conditional formatting on these, and then you can do a report page tooltip based on your trigger. So it's a little bit of a workaround, as it usually is in Power BI. Yes, yes. So yeah, awesome. Thanks. Perfect. Okay, well, I might stop sharing then, and we've got opportunity for Q&A at the end. And I'm going to hand it over to Daniel, who's going to talk about a very specific approach when the core visuals just don't cut it, of how we can have a look at visualizing meter-specific guidelines in one chart to show all of your bores on one chart and flagging whether or not we've got an exceedance.
Thank you very much, Alice. Hi, everybody. I will be brief with my intro. So I'm Daniel. Alice did a lovely intro at the beginning because time is short and there's lots to do. So if you could just bear with me, I will share my screen. I'll do a quick framing of the problem and then a whistle-stop tour of what we've done to solve this. So there may be many questions. As Alice says, we'll try and make some time for Q&A at the end. But to sort of frame our problem here, this is a very simple, and because I'm working at a visual level, a visual you can think of as having its own data set. We're just using a simple data set to illustrate this, not a model. So this is a table where we've got a number of sample points and a number of values that come in on particular dates. And we have what we call the trigger level and the investigation level. So these are thresholds that we wish to flag our visual against. We want to be able to encode those states for our readers. So what we also have, we use a measure here. Let me just zoom that in a bit. So we've just got a measure that takes our average groundwater level, and that's just simply taking the result value from this table. So when we aggregate this data, Power BI will average that up for us. And then we have this other measure here called daily groundwater level status. So just to unpack this, what we're doing here is we're getting the investigation level and trigger levels summarized in a similar way, like we did with that other measure for the groundwater level. And then underneath here, we're just doing a very quick conditional statement to say, based on which condition is true. So if our groundwater level is blank, we just make it nothing. But otherwise, if our groundwater level is greater than that investigation level, we say it's non-exceedance. So this is a textual value that the reader can see. And if this level is, so if we don't hit this, we fall down to the next one, which is if the level is bigger than the trigger level, we say it's below the investigation level. And then if all else fails, it's below trigger level. So this is going to give us basically 3 values when that measure is evaluated. So what we had was a scenario here where we have basically what we say is too many dimensions for a core visual in Power BI. What I mean by that is we want to be able to plot all these values, and we want to be able to visually encode the exceedance state. So as we've just, this daily GWL status measure, we want to be able to encode that on a visual. So our particular challenge we had here was, this is a core visual here, a line chart. And this is somewhat limited, but I'll sort of use this to highlight the challenges and Alice's notes for me when we talked about this problem, just to sort of summarize the problem. So what we wanted to be able to do was to have one line per bore in this case, and then we wanted to be able to plot that average level over time. But what we've got here is these little points that sit on the top. We can see there's a gap here, but there are points, and we want to encode those points with a value of red, green, or orange based on whether they're a non-exceedance, whether they're below investigation level or below trigger level. We also wanted a legend. And the other thing was, if we look down here, hopefully this will work because sometimes Teams messes it up. Let's see. Alice, did that zoom in okay?
Yes. Yeah. That's
awesome. Normally the screen goes off, so I'm glad. But at the bottom there, we can see that's 93,000 rows. And one of the challenges with the Power BI, and it's a sensible challenge, is that a lot of the core visuals are actually limited. So we can see here that we only have a certain amount of data points, so we're not able to visualize all of our data points. So we've got a couple of challenges. Firstly, yes, we can separate, well, we can plot the date on our x-axis as we've got here. We can put our groundwater level on the y-axis, and we need to split the lines. So we're using the bore fields to create these separate lines, but now we're sort of stuck with how to decorate this. And if we have a look in here, we've got markers enabled, but we can't conditionally format their color. So one of the first things we might think to do is to say, let's look at that GWL status measure and conditionally format those points. But unfortunately, we just can't do that. And we have the issue of too many data points to visualize. So I think the line chart will do about 3,500 data points, which is way below what we need. So what often happens is, and this happens a lot with environmental data because it's outside the realm of the normal financial data that Power BI may be used to visualize. What often happens is sometimes the core visuals just don't work. And a lot of what I do is developing what we call custom visuals. So for those of you that aren't familiar, you can choose these normal visuals off the palette. And often you may have to torture them to try and do what you want in these situations. But you can actually look in a marketplace for custom visuals. And custom visuals are written by third parties, so developers that actually try to identify and solve additional problems in Power BI. So there's currently over 700 visuals that you can look for, and a lot of them do very specific things. So for instance, we have ZebraBI here, which is a very good financial modeling and visualization set of visuals. We have, a water cup, because, you can visualize, is the glass half full, half empty? But these solve challenges that people are looking to solve in Power BI. These visuals typically have very specific purposes and do one specific thing. So much like you would have the bar chart or the pie chart, you will try and find a visual that solves your need. What we're sort of thinking about here is I've been developing visuals for a long time, and more often than not, people they don't necessarily know what they want, but they have a problem to solve and they want to be able to play around and develop. And you usually have to be a web developer to do that. So one of the things I've tried to solve over years is to create a visual called Deneb, which we talked about and is available in App Stores. Deneb is a little bit different, and we don't have time to do a full walkthrough on it. This is more about how we used it to solve a problem. But you can add this into your report, and Deneb is more of a what we call a visual grammar, and I'll just talk a little bit about that in a second. But just to sort of show you where it is, we can add the visual just like any other visual. Deneb has a website, so I'll just pop across here. So deneb.guide is the URL. For those of you that may have heard of Deneb before, there was a previous address, and that still works. This will redirect you here. But Deneb allows you to use two different languages. So much like how Power BI exposes of course, the tooltip would show there, the R and Python visuals, which you can see in the palette there, which do let you code a little bit inside Power BI, but have some limitations. Deneb has the same philosophy in place. The difference is we expose two additional languages here. One is Vega, which is what's known as a visualization grammar. And what we mean by that is rather than taking a chart that you think you need and trying to make it work how you think it should and possibly getting annoyed with it not having all the features, it actually lets you start with your data and describe how you wish a visual to be built using what we call marks. So a mark could represent a bar or a line or a point, but also how those marks are encoded. So when we talk about encoding, that's mapping them to certain things like the X position or the Y position. And that gives us a lot of flexibility. We can also layer them and split them apart and encode their properties to data as well. So color, transparency, those kind of things. So Vega lets you produce a lot of powerful, some simple visuals, but you can actually start to produce some very powerful scenario-based visuals that you can't usually do with Power BI and some custom visuals. But we also have what's called Vega Lite, which is a simpler version, which is more geared towards common use cases. So I often play around in this one more when I'm building, just because it's faster than the prototype and it's usually pretty good. But again, you can see it produces a range of different chart types, simple ones, not so simple ones. And again, I'd love to spend time on how cool this is as a language. But we do have on Deneb's site, for instance, just for those that are hearing about this for the first time, we have documentation for how the visual works. We have a community and resources page because Deneb is a free and open source visual. So lots of people have produced lots of templates, lots of guides. So if you want to have a look on your own time, if this seems a little bit daunting to you today, don't worry too much about it. Lots of people have got your back. But for brevity's sake, what we ultimately want to do is to think about, can we use the visual like Deneb to solve the challenges that this core line chart visual can't fulfill? So just a very, very quick intro. So if I just do a very quick core bar chart, just to show differences, if I take my my sample point and my groundwater level, I get a really simple, this is not an exciting bar chart, but just to show you that we're kind of aggregating and measuring. The way Deneb might do that is more like a table, where if we have our sample point, that's a grouping column. So we get a row for each value, and we get our groundwater level aggregated. We can add Deneb through the App Store. I've already added it to my report. This just gives us a visual landing page with some very specific instructions as to how to get started. You need data, then you create a visual, and then you experience it, or your users do. So I can treat this like a table visual where I'll add my sample point and my groundwater level. And when I have data, I have an option at the top of my visual to actually go into what's called an editor. So not all visuals have this, but this will open up a completely different user interface where we can start to build a visual. And for time, we've just got a couple of simple inbuilt ones just so you can see how things work. And these allow us just to map. I'm just going to map my sample point and my measure. So this is kind of mimicking the bar chart that we've seen, but I just want to give you a quick insight into how you might build a similar visual. So let's just make that font a bit bigger. But on the left, we have an editor, and this is the language, which is a very simple directive based. So this is not full code. This is what we call a visual grammar. So it's just simply saying, take our data set, which is here, and visualized underneath. We can see we've got 10 rows. Add a mark, and that's going to be a bar. We have other types. So we've got arcs, which are curved lines, areas, bars, box plots, and so on, lines, points. So you can think about your visual as primitive elements. So what we're saying here is this is a bar. And what we then do is we map properties of that bar to data. So what we're saying here is for the y-axis, which is our vertical axis, use the sample point, and that's going to create 10 spaces for that and create an axis for them. And then with our X encoding, we're going to take the groundwater level, and that's going to set the width. So we've already got a really powerful bar chart with axes and everything else that we normally might have to do a lot of work in web development to do with some very simple JSON. So JSON being a data format rather than code. I do tend to use code and JSON interchangeably, and you can think of it like code, but it's ultimately very simple. But on this premise, you can actually do some very sophisticated things. This is probably the simplest you can do, but you can basically build, if I want to change that to a line, if I want to see what a vertical line chart looks like, I can do that. It's probably not a good idea, but I can try it. If I want to change the orientation, I can just swap the X and the Y around. And now I've got a different visual, but I can use this grammar to take my data and almost like Power Query for visuals, where we start with something and we can transform it and shape it and plot it. So I apologize for the very, very short intro, but what we want to do is see about how we can think about this problem. Instead of thinking about it like a core visual, how do we think about it like a visual we build from our data? So what we actually have, if we start here, if I take my table visual, I've got a slicer for reasons, which we'll talk about in just a second, but I've got my slicer for sample points as well. But just to show you my table, all the data I'm going to need, I've got my date, my groundwater level, so that's my date by measure by date. I've got my bore, which is my sample point. I've got the result of my measure, and I can see that each one of these is either below trigger, below investigation. It's a non-exceedance, but this is being aggregated and evaluated for every combination of bore and date. And then I want the extra things in my tooltip. So I've got my investigation level and my trigger level just for information purposes. But this is my visual data set. So what I can now think about is, well, I want the date on the x-axis. I want the groundwater level on the y-axis. I want the bore to be how I split my data. So that's a series. And then I can actually think about other things as things that I can encode to my different properties. So I'll just make that visual available just to sort of jump ahead a little bit. So what I've done here is I've actually worked out that, and we'll just filter it to one bore just to show you. I can actually have a line, and let's make the data bit narrower. So what I can actually do is have a line for each bore, and let's add bore 6 on as well. Maybe bore 5. No, none of them are close to bore 7. That's close enough. We can see that we're able to create this separation. We've still got the X and the Y and the split, but we can also now add this conditional encoding where we've actually got some green, we've got some yellow, and whilst we don't have any red, we've created space for it so that somebody can understand. And we're kind of teaching you to run super fast here from going from this was a bar chart to this is a whole other thing. But what we can do is we can break this problem down into what we call layers. So we had a single, let's just make that JSON a bit bigger. We had a single mark before, which was our bar, but now we can actually break this into a layer problem. So we actually create a line for the groundwater level, which is the line in the background, this gray line. Let's just comment those out. So this top layer here is just a line. And what we've done is we've plotted the X and the Y against the date and the groundwater level, and we've just done a little bit of customization to the axis and a few other things, but ultimately that's what we've mapped those to. And we've added this field, this additional encoding called detail. And what detail does is it means split it out by another series, which is our bore. So now we've got 2 lines. If we didn't have detail, we'd get this really weird jaggedy line that went all over the place because the visual doesn't know how to break it up. So we actually have to define that. But that gives us a dimension that we can actually start to build a visual design by. And then finally, we have what we call the tooltip channel. And we've actually started to bind our date, our bore, our groundwater level, our status, and all the fields, plus some additional custom number formatting, which is quite a powerful feature as well. And we can sort of hover over a data point and get our tooltip. So we're starting to get there. But the second thing we did was another layer. And let's unpack that now. So we'll just reapply that change where we can now see all this other stuff. In this layer, we've gone a little bit more elaborate. We've added a point. So we're now putting a point over the top of our line, and the X and the Y and the detail and the tooltip all get inherited because they're at the top level. But now we've added an extra encoding called color, and we've said bind that to the GWL status field, and it's got a range, so a possible set of displayed colors of green, orange, and red. We want to be able to manually assign those. They could be measure driven if we wanted, but for this purpose, it's quite straightforward. And then our domain, which is our list of available values, non-exceedance, below investigation, or below trigger. So again, these can be done dynamically, but because our visual has a very specific use case and we want to be able to be very prescriptive about what's done, we've set this up manually. But we've just been able to very quickly do this. And whilst it seems daunting that was done with some JSON, when you understand how this works, you can actually start to learn to think visually very, very quickly. So you start with your data and you can start to see how things are built. So if any of you used R and ggplot, for instance, it's the same paradigm. You can actually just take a data frame and turn it into a visual very, very easily. And then you can start customizing it very easily as well. So you can get the data layout working, you can get the encodings working, and then you can customize every little bit instead of hunting through the properties pane and trying to find what you need. So one of the challenges with our approach is we're still looking at the volume of data. So Deneb actually has the ability to override the normal row limit and actually ask Power BI for more data. So we can actually recursively load our data from the model, where we've got more than, in Deneb's case, 10,000 rows is the initial limit, but we can ask for more. So we will be within our requirements. The problem is because now we're drawing a point for every single data point. This is the equivalent of having too many visuals on a page, but on acid. So what that means is that all of a sudden we're going to be pushing possibly 10, 20, 30,000 extra little points into a visual. And each one of those is a little circle that gets rendered. And the reason I have so many slices on this page is because that's, whilst the visual can handle it, the actual displayed visual will blow up Power BI. So that's not a great outcome. So I can solve the problem, but I'm causing a performance problem. And this is one of the reasons why core visuals are quite low in their demands, because they want to keep performance tight. The idea with the visual like Deneb is you are in control of the visual, and these are risks that you have to mitigate, but you can push these boundaries a little bit further. So one thing you can do, and we'll just flick across to this page, is we can see here this is actually loading more rows because there are no filters applied, and we now have all the bores and all the states and everything else. We can actually change the way the visual is rendered using Deneb. So in this editor, which will take a little bit longer to open because there's more data, but we can see the 17,000 rows here currently. Under settings, we can change the render mode from canvas to SVG. So SVG is scalable vector graphics. That's the nice, crisp, clean, scalable modes. But that's the one that causes all the, when you've got too many shapes in the page, that's when you have performance issues. Canvas allows you to render all of these data points as, for lack of a better word, a static image, but you still get the tooltips and you still get the interactivity. But the trade-off is, and it's probably easier if I zoom in a bit, because it's not scalable. When I zoom in, you can probably see the font of the matrix next to the visual. It's a little bit blurry. So whilst you get the additional data and you get the performance of not having to have so many shapes in the page, you get a little bit of blurriness. And this was actually okay for our client. They were actually okay with that, but I wasn't, because I'm stubborn like that. And I just wanted to have a little think about that. But one of the other things that I didn't like, if we zip over here, is if I've got a subset of date already chosen here, but if I choose, say, bore 7, this point approach, what I don't like about it is where you've got, even though this is continuous, you've got this kind of, it almost looks like a break. So this green state, it's actually supposed to represent every day it's green, but we don't know as a reader if that's actually true or not because it's not continuous. So what's happening is we're drawing a point for every date, but they're not joined up because they're points. They're like scatter plot marks. So this, for me, is a slight issue, and I can see this with, say, bore 6 as well, where I've got a break here, so I can kind of infer it. But here, where it's a bit more tightly distributed, I don't know if there's a break in there or if it's just the angle of the line. So one of the things I did have a look at, and I'm very conscious of time now, is the one on the right here, which actually shows a continuous line. So if we'll just blow this up a bit, hopefully it'll go over the top. This scenario we had before with the broken lines, what we were actually able to do was think about the problem a bit differently. So what we can do with the languages, the Vega and Vega-like languages, is we can draw lines instead of points. And because of how we can control the line, if there's missing data, we can actually, for lack of a better expression, lift the pen, take the pen across the canvas and put it back down. And that's still one shape. So what we're actually doing here is we're able to, and this is a little bit of lateral thinking, and we'll just zoom that to fit. What we actually did was came up with and one thing I like about this is that we can put comments in. Instead of having 17,000 points as we just saw, plus 4 lines, we can actually think of it, instead of having, for each bore, we have 1 line for the gray background line, and then we have 1 line for each state of the status measure, and we just lift the pen when there's nothing to draw. So this green line that we see here is actually a single line, but it's broken because we remove the data and then, almost for lack of a better word, impute that data. So the dates are missing, but we create empty date values and put them back in. So this is what we're actually able to do in this visual, is also do what we call transforms. So we have our data, but we can actually manipulate it much like we can with Power Query. And continue to evolve visual, not just from the data we have, but also to shape the data and do other things to it. So we can do calculations, or we can pivot or unpivot using these languages. So we're actually able to think about the problem in a slightly different way and use these data streams that get created. So we have our base data set here, which is currently 711 rows. But I can actually, for each layer I create, I get a little stream of data that I can transform. So for instance, if I come into this one, I start to get some additional columns in here where I'm actually calculating some extra things. And I've got 735 rows now, for instance, because I've actually created some missing data points for values that are missing for each line. So I'm actually able to manipulate the visual and transform it and move it further. So again, this is probably more of a detailed study of its own, but it's just to show that we can actually start to think about a visual as a something we can evolve and build rather than something we're kind of stuck with. And just to finish off Alice's requirements, this is a more complete example where I've just added in some grid lines and I've just put the legend up the top, but we've still got this nice continuous line. And what's nice about this, because it is only now 4 marks in this example instead of several hundred, I can move it back to the SVG, and it means that if I zoom in, I get a really smooth visual instead of a blurry one. So we're actually able to make it look like it sits at home inside Power BI, which is really, really nice. So I think I will stop there. I can go on and on and on about Deneb and what it can do for you, but I would suggest probably having a look elsewhere at that. This is just about how we used it to solve a very, very specific real-world problem for a client, and how you might be able to start thinking about it. If you use R and Python, Deneb is a very similar paradigm. The difference is that it will work anywhere the R and Python visuals don't work. So you can use it in publish to web, you can use it in mobile reports because it's all included. And that's one of the most important things. And it's also certified as well. So for those that know custom visuals, certified visuals have been reviewed by Microsoft to be safe in terms of data security. And also you get extra benefits like being able to export to PDF, include them in emails, and that kind of thing. So I think I've probably covered as much as I can cover in 20 minutes and a little bit more. Thank you very much for your patience, and I will yield the floor.
Thanks so much, Daniel. That was a really good walkthrough and a really good example of just with these guidelines and exceedances and triggers problem, people always want to visualize it slightly differently. And that was a really good use case of using Deneb to solve that problem. And just while you were talking, I was thinking it could be a good one, much less kind of requirements, but with environmental data, we often have maybe we've got rainfall or groundwater levels, and we really do want to see where the gaps are because Power BI automatically connects our data together, and that's really misleading. So that could even be a good application for that approach where you're lifting the pen to show those gaps. There's so many applications.
It's probably one of the biggest differences between how the core line visual works and how the actual sort of visual grammar approach works. Instead of kind of just creating a line from one to the other and you inferring that maybe there's a gap, I don't know, you actually explicitly see the gap, which I think is really powerful when it comes to these kind of things.
Oh, thanks so much. And there's so many different ideas we've got for visualizing exceedances with Daniel's amazing Deneb. But were there any questions or comments, or people want to share their experience trying to visualize guidelines or exceedances or triggers in Power BI? Just while you're thinking, I see we got one. We had a couple of questions from Jerry, just about do people use the DAX query view in Power BI? I don't. I had a look at it. You use it? You love it?
I do. It's
I
great.
thought you would.
Yeah, it's
I
awesome.
said Daniel probably has.
I use it quite a bit to explore. I do still fall back to using DAX Studio if you're familiar with that. That's kind of the third-party version of what the DAX query view was started out to be. But it's really handy for exploring and testing your queries out. It's very neat. I do like it a lot.
It's good. There's lots of new functions being added on, like functionality in Power BI all the time. So it's good to keep up to date with what all the extra buttons and toggles are. And Jerry asked a follow-up question, what's the best way to use DAX to design profit and loss matrix versus target in a single table? And I said it really depends. There's a lot of different ways, and it's really kind of tricky.
Yeah, I think P&L is an interesting one, particularly where you often have very specific line items and how accounts may roll up, and they're not necessarily, conducive to that hierarchy. So I guess my initial thought is there are some custom visuals that make it easier in terms of that design. So Zebra BI, InfoRiver, those kind of visuals are really good and almost purpose built for those kind of scenarios. If you are stuck with core visuals, I would recommend having a look at the SQL BI website or the DAX Patterns website. So that's Marco and Alberto, who are kind of like world leading DAX gurus. I think most of us have learned from. They've got some really good patterns for how to look at that. And then there are some great people on LinkedIn who are really playing with the core visuals and this new visual calculations feature, which is still in preview, but very, very powerful. Where you can't necessarily change the row layout of a data set like you can in Deneb, but you can actually calculate some things in the context of the data rather than the data model. Gustav Dudek, Eric Svensson, people like that are really neat people to follow just to see what they're doing and pushing in that space. But it is a real it depends answer.
Amazing. Kobe, I think you had your hand up before. Have you got a question?
Oh yeah, no, it's just a bit of a tech question. You're talking about the performance issues if you're throwing too much at it. Where's the bottleneck for that? Do you think is that in the software or dependent on the system computing system that you're using in terms of hardware, or is it the viewer? I guess where's the bottleneck?
They're all over the place. So I think the primary bottleneck for something like this, I mean, if you're talking specifically about presentation, SVG itself is a great. You can see it's nice and crisp and clear, but you're putting a lot of things in a web page. So each data point is a circle, for instance. It could be a square or a triangle or whatever, but every one of those points, you're adding extra things into your web page. So I think, as I said earlier, it was a bit of a blur, but it's kind of analogous to putting too many Power BI visuals on a page. They've all got a kind of footprint. So adding too many data points creates too many shapes. You've got to be careful to balance that. But at the same time, sometimes, like the technique I use to minimize that by using lines, you may get a bottleneck further up. So DAX, for instance, is not a great language for projection. When I talk about projection, what I mean there is it's very good at aggregation. So, taking columns and grouping and aggregating. But if you want to do something like a box plot or a violin plot, something where you need to do statistical analysis and you actually need to get as many rows as possible, that's an expensive operation because it's just very anti-DAX. So sometimes you can have a good performing visual bit, but the query itself can be very bad. And again, I hate to say it depends, but there's potential choke points at any part of the solution, really.
Yeah, it seems like there'd be a lot. Yeah, especially, if you're accessing this by the web page as a viewer, I guess it's bandwidth dependent, and then it's processing on your end, and then I guess that's the benefit of it's like raster versus vector, the old chestnut in GIS.
It really is,
and simple's better.
It really is, and the core visuals, as I say, they're limited for reasons of performance and to protect you from basically killing your desktop instance or your reader's web browser, because these are things that are hard to govern when you let them through. So with Deneb, we sort of take the rule of if you're already in there, you're probably trying to get more out of visual, and therefore you're probably aware of the risks.
Yeah, it's a good point. It's the price of beauty, isn't it? Nice visual.
It is. It's all a trade-off. Someone's paying somewhere.
Awesome. Thank you so much. Are there any, I see there's a few comments in the chat. Any other final questions? Jerry asked, any tips for data efficiency about loading data, either on Power Query or DAX? he's got a huge data set, multiple data sources imported into a single Power BI. The refresh takes a long time to refresh. Yeah, so I think that could be another. It depends.
There's a whole, you can do whole days on this, but a short answer will be try and fix it as close to the source as you can. And, you know, the better, the closer it is at the front, which is why Power BI works great with enterprise data as well, because a lot of people often have SQL databases that are already kind of nicely refined. Most of the situations we see are the opposite. And sometimes you just have to look at, you know, is it possible to consolidate the files at the source a bit more easily instead of having to load hundreds? Can I load maybe 10? Yes, I've got to smoosh those together myself, but the cost might be worth it. And then there's possibly other techniques you can use to improve the performance of Power Query, because sometimes Power Query, and Alice and I were talking about this earlier, actually, Power Query likes to evaluate itself a lot more than you probably want it to, but it has to keep doing that. So sometimes you can be querying continuously, and that comes at a cost. So again, there are people probably worth following on, certainly on LinkedIn, that, and off the top of my head, I'm really struggling. Rick de Groot is one. BI Gorilla, I think his site is. He's very Power Query savvy. Win from Perth, he's really good at Power Query and that kind of stuff. Chris Webb, who's from Microsoft, did a lot of stuff on before he joined, and since he's joined, on optimizing those kind of things. But there are people around that are doing whole articles on this stuff, and you can get really deep into it.
Amazing. We might leave it there. I'll just quickly share screens again. I'm happy to stay on if anyone has any extra questions or you want to chat about your experience. We work a lot in this space in the environmental industry, and every project is different. They have different requirements, so there's no one size fits all. But hopefully that was enough to give you a flavour for the type of challenges that we face, a couple of ideas for visualising and modelling it, and then where it doesn't just fit, then we've got the option Daniel presented as well. So remember, if you wanted to watch this session or share it with a colleague, we'll put it up on our blog and YouTube channel probably later in the week or early next week. So stay tuned there. And if you want to share your environmental data analytics story, or you've got a really good use case, no matter how simple or how complex, we would love to have you on. We're always looking for speakers, so please get in touch with Christian or myself just on LinkedIn. I think next week we've got tentatively booked in. We're just sorting out a date. We've got Greg Nash. He's in Melbourne. He runs the Melbourne Power BI user group. He's going to be presenting on using AI for environmental data analysis. I think making something on the fly with maybe Copilot or ChatGPT. So that will be really interesting. All about using the AI technologies in Power BI. So that will be really cool. We've got a couple more in the works, but yeah, please reach out. And thank you so much for dialing in. It's always good to see familiar faces and new faces at our meetup. So please spread the word, and hopefully see people next month for our next one. So thank you to Daniel. Sorry.
Oh, no,
we worked together, so I forgot. But thank you so much for Daniel for taking the time to present.
No, thanks for having me. It's always great. Like, considering we work together a lot, I don't always get to these. Sometimes I'm busy doing stuff, and I would love to come to more. But it's always good to come along and be able to talk about what I love. So thank you. And I got a very nice question about Lego, so I've answered that.
Amazing, all your cool things in your background behind you. So thanks for
and many around the house.
Yeah, thanks for jumping in. If there is, does anyone have any final questions or things you wanted to ask? Stop the recording.
Yeah, I'm totally happy to answer anything else. Also happy to let everybody go if they want to go. Get on with their day.